Hi there, let's deal with topic one in our unit on water. In particular, I want to talk about the problem with the way water is situated on Earth and also about the importance of the water cycle. So what's the big deal about water? Well, water, as you know, is one of the key ingredients to all living things. And unfortunately, as far as the world goes, humanity's greatest problem right now is getting fresh, clean water to everybody. So keep this in mind, over 1 billion people are without safe water, and over 2 billion people in the world are without proper sanitation. 10% of the world's food is grown with water from aquifers, which are being depleted faster. And we'll talk about these underground lakes later. And in many parts of the world, access to water distinguishes those from who are poor to those who are not poor. Very interesting stats here regarding water quality. This tells you the percent of access to clean drinking water. And as you can see here, the lowest graph, which is about a little more than 50%, is Africa. And so it tells you the grave condition that lots of African people are in when it comes to access to proper water. The best, obviously, is Europe and Central Asia. North America isn't on here, so I can't tell you where they would sit on this graph. So this is in red for a reason. In the next 30 minutes, about 130 children in developing countries, that's basically 6 kids per minute, will have died from disease caused by unsafe drinking water. And in 1990, 3 million deaths were attributed due to diarrhea and 4 billion episodes or more. So children under 5 are the most vulnerable, and they account for more than half of it. Here's another stat from the World Yearbook about water. This light blue tells you inadequate water supply, and then the dark blue tells you no water supply whatsoever. And so predictions are by 2025, over 3,000 million people will be suffering with inadequate water, and approximately 500 million people will be with no water. So it's a growing problem that the world needs to embrace and start to think about changing. Why is it such a problem? Well, most of the world on Earth is made of water. However, it's tied up in the oceans. And so if we look at all the water on Earth, 99.7% of it is unusable. And the reason it's unusable is that it's in saltwater form. Only 3% is in what's called freshwater form. And then of that 3%, the majority of it is locked up in ice, which is hard and takes a lot of energy to melt. And so 22% is groundwater, which is underground. So a measly 1% of this 3% is surface water. And even then, surface water isn't automatically potable, which means drinkable. So here's the tiny percent, that's 3%, that's usable because it's not salt. And of that, most of it is underground, which takes a lot of time and energy to pump up. And a small percent is fresh from lakes and rivers, which we'll get into. So water is an issue on Earth because most of it is unusable for humans. Let's talk about the water cycle for a minute. There are stages to the way water is circulated, which makes it a potential hazard. If you dump, for example, a chemical here into this freshwater storage, it's not going to stay put. It's going to move around and possibly contaminate the rest of the ecosystem due to the hydrological cycle. So there are steps that we need to remember in regards to how water does move in a cycle in our environment. Let's start with evaporation. So water from oceans and seas, thanks to the heat of the sun, will evaporate into water vapor into the air. That's step one, that's evaporation. Step two, all that water vapor will eventually coalesce, join together, and form, through condensation, clouds. Step three, those clouds will eventually drop their moisture in the form of precipitation. And higher up in the mountains, that precipitation starts to head back down through streams and rivers and groundwater, back eventually to the oceans through runoff. We also, in addition, we might call evaporation 1A, and we'll call transpiration 1B. Transpiration is the evaporation of water from plants, and so that's an important part to the water cycle as well. Again, global water distribution is a little bit scary. Here it is again, of all the Earth's water, 97% of it is saline, which is salt, and 3% is in freshwater form, which still doesn't mean it's drinkable. And then let's take the freshwater. Most of it is tied up in ice caps and glaciers, and a small percentage of it is groundwater. Then look at the tiny bit that's surface water. Of the surface water, 87% of it is lakes, 11% swamps, and a measly 2% is rivers. Let's see if we remember the water cycle. So let's label our diagram. What would we call diagram A? If you said evaporation, you're right. What would we label B by the cloud? If you said condensation, then good job. What would we label C? If you said precipitation, way to go. And what would we label D? If you said runoff, nice work. The only thing that's missing here on our diagram would be in the evaporation process, we might get transpiration, which is the evaporation of water from trees. Transpiration helps move water around. There we go. Let's look at a quick video clip about the water cycle before we end this session.
Condensation is the transition of water vapor into liquid water. Tiny water droplets suspended in the atmosphere form clouds. Precipitation occurs when water falls as rain, snowfall, or hail. Infiltration occurs when surface water moves downward into the soil. Percolation involves a downward movement of water through soil and permeable rock. Most precipitation flows into streams or other bodies of water as surface runoff. Groundwater flows slowly downhill through porous rock and seeps out into bodies of water or comes out as springs. Evaporation is the transition of liquid water into water vapor. Transpiration is the evaporation of water from the leaves of plants.
That's our first topic, or a quick overview of our first topic on the water cycle and global water distribution.